Let us continue from where we left behind. In my previous video I have discussed about the different properties of an element. We have already discussed two properties. The one was atomic size. What is it? It is the distance of the outermost electron from the nucleus, okay, and its variation across the period and down the group. Secondly, we have discussed the ionization potential. Definition was an atom, the energy you need to supply to an atom so that the loosely bound electron of the outermost electron is lost, okay, and the various factors which was influencing the ionization potential. Today I will be discussing the rest three properties. The first one would be electron affinity. From the word itself you can easily guess what is an electron affinity. Affinity is to have affection towards something. So here something would be the electron. If an atom has a tendency to accept electron, some energy needs to be released. That loss of the amount of energy you need to release for an atom to accept an electron to form an ion is called electron affinity. But remember one thing, in case of ionization potential you were supplying energy, in case of electron affinity you are releasing of energy. The second difference is, in case of ionization potential you were forming cation, but in case of electron affinity you are forming an ion because you are accepting an electron. Due to acceptance of electron, an excessive negative charge develops over the atom, okay. Just as we have discussed the factors which were influencing your ionization potential, atomic size, here also we will be discussing the factors which will affect the electron affinity. The first factor is the atomic size, okay. As atom is smaller in size, therefore it will have more tendency to accept electron, okay. Why? Because in case of a smaller atom it will have the nuclear attraction on the electron would increase because of the smaller size. The nuclear charge is more, so it will accept more electron. As it is accepting more electrons, so the electron affinity increases. So what is in brief what we can say? Atomic size decrease, a smaller atom, E A increase, okay. Similarly is just the second factor is the nuclear charge, which is just the extension of the atomic size factor only. Why I say, when you are explaining the atomic size factor you need to introduce the concept of nuclear attraction. If you are able to introduce the nuclear attraction concept, you are automatically dealing off with nuclear charge concept. So if more is the nuclear charge, therefore there is a more tendency of an atom to attract more electrons, so EA increases. Now we will see the trend across the period and groups, okay. How electron affinity varies across the period. We have discussed in the previous lecture, atomic size decreases across the period because of increase in nuclear charge and number of shells does not affect. As atomic size decreases, the tendency to accept electron increases because of the smaller size, okay. As a small electron acceptance tendency increases, so electron affinity increases, ठीक है. Similarly, if you have to explain on the basis of nuclear charge, what would you say? Across a period, nuclear charge also increases. Nuclear charge, okay. So if more electrons are accepted, there will be greater attraction of electron towards the nucleus, therefore electron affinity increases. Clear? We move on to the next one, that is down the group. Here also same thing you need to explain, just as you have explained for the ionization potential. Down the group, atomic size increases because of number of shells. So you are going away from the nucleus. As you are going away from the nucleus, your power of attraction decreases, because nucleus won't be able to exert same attraction on the atom which has a larger volume. Okay, therefore your tendency to accept electron also decreases. Therefore your electron affinity decreases. Down the group I have written decrease, it is increase. But also we have said nuclear charge down the group increases. So electron affinity should increase, but the atomic size factor predominates over the nuclear charge factor. So we see overall decrease. ठीक है, क्लियर हुआ यहाँ तक? The next property is the electron negativity. Electron negativity is nothing but, suppose two atoms are combined to form an compound. Okay, so the tendency of an atom, okay, to attract this shared pair of electron towards itself. I am writing a bigger one. A and B are two atoms which are involved in formation of a compound. Therefore, they will be sharing electrons to form bonds. If the tendency of any of this atom, I am taking for in case of A only, if the tendency of atom A to attract this shared pair of electron towards itself, this phenomena is known as electronegativity. Therefore, if an element has more power to attract the electron towards itself, it will be more electronegative than the other one. Okay? A and B, I am saying if A has more tendency than B to pull bonded electrons towards itself, so A is more electronegative than B. Okay, so what is the definition? Tendency of an atom, keyword, attract the shared pair of electrons towards itself. Okay, so what will be the factors? Same factors, just used to study the influence for electron affinity. Okay, so what we can say, as the atomic size increases, EA will decrease. Why? If you have a smaller atom, it will have more tendency to pull electron towards it, come towards me. But as you go away or become bigger inside, it will have no such tendency. Okay, similarly nuclear charge, obviously positive, more positive charge you have, more it will have a tendency to pull towards itself. Therefore your EA, electron affinity, electron negativity would be more. How it varies across the period? It will increase only. Why? Atomic size decreases na across the period, as well as nuclear charge increases. So both factors contributes towards the increase in electron negativity. ठीक है. Now for down the group, atomic size increases because number of shells will increase. So EA is your electronegativity decreases. Your electronegativity and electron affinity, this both the properties vary similarly because both have the tendency to accept electrons only. Okay, one has to pull the electrons, or one has to accept the electrons. And down the group also nuclear charge increases, but in all the previous cases we have seen this atomic size factor will predominate over the nuclear charge factor. Here also the atomic size factor predominates over the nuclear charge. So overall electron affinity decreases.
Thank you everyone. Please do like my video, share and subscribe it.